Hello again, our most valued student. My name is Confident and welcome to AgroLenTech's 24-minute lesson. Our lesson today is a continuation on exponents, sets, and logarithms, and more importantly, we are now looking at logarithms. Let us go straight and look at the laws of logarithms. We have got 6 laws of logarithms that we're going to be looking at, as well as ln. So let us dive quickly to each and every law and how it applies. Remember, when we're talking about logs, it's similar to the laws of exponents, but it is an inverse. In other words, they usually oppose kind of exponents. Now, look at the first law. If you're given log a, log in base, remember, just to remind you now, when you're given something like this, log, and then you got that, the power. So a is the base, x is the number, and 2 is the exponent. So it's log base a of x squared. So when you're given log in base a of xy, you are saying when the numbers are multiplying here, you are going to split them as log base a of x plus log base a of y. For example, look at this question given, log in base 3 of 5 plus log in base 3 of 6. This, you will read this law going backwards. We are saying because of the plus sign, the law says if there is a plus sign, you multiply. So here you will write log in base a, we've got a 3. Then after that, we're going to put a bracket, say 5 times 6, that is xy. So this is same as log in base 3 of 30. That's what it means by using the laws of logarithms. In other ways, also, if they give you log in base 5 of 2x, this is same as log in base 5 of 2 times log in base 5 of x. That's what they mean using that law, but in this case it is going in that direction. The next law says if there was an addition, remember there is a multiplication, there is a division, which says log in base a x over y. Whenever there is a division, you subtract. You can see the subtraction line in a division. So now, given this law, now we're reading the law again in the backward direction. What are you going to have? Here it says log base 3 of 36 minus log base 3 of 6. Because they are subtracting and the bases are the same, is same as log base 3 of 36 over 6. This is same as log base 3. 36 divided by 6 is 6. Another one, log 100 minus log 5. If they just say log 100 minus log 5, the assumption it is that it is in log 10. So when you see log 100 minus log 5, this is same as writing it as log base 10 of 100 minus log base 10 of 5. Because of subtraction, it will be log base 10 of 100 over 5, which is equal to log base 10 of 20, or you can simply write it as log 20, because by leaving out the number we know that automatically it is a 10. The next law says log base in base of a x to the exponent of n. What happens is the n drops. So just to put this law together, it says log a x to the power n is equal to, what I want you to see is that the n will come this side. So you will have n and then you write it as log same base with an x. The opposite is true. Sometimes you need to take the n back. When the n go back, it's an exponent. This is that law. And this law number, okay, let's first go to this law and make an example. If you are given log base 3 of 27, now you know 27 is the same as log base 3. 27 is 3 to the exponent of 3. Now, using the previous law, this 3 will come and go before the log. So you are going to have 3 log base 3 of 3. Now something is interesting that will make me to go to law number 5. It says log base a of a is equal to 1. Log, if the base and the number are matching, you get a 1. Now look at this one. We have got also similar version, AA. Now you have got a 3 and a 3. It means this is same as 3 times 1. The answer now becomes a 3. What about log 100? Log 100, remember, is log base 10 of 100, which is equal to log 10 squared in base 10. Remember, 100 is 10 squared, which is equal to, you drop the 2, which is 2 log base 10 of 10. Again, you have a similar scenario where the 10 and the 10 are matching. So this is same as 2 times 1. The answer becomes a 2. Remember, punch this in your calculator. It will give you the similar answers. The next law says log base a of b. This law is used to change bases. When you're changing the base of a log, then you are going to use this law. In other words, you want to change base a to base c. So it will become log a. You can see a is the one that goes below the sign, and b, which was the number, goes on top. And again, we did this law, log base of a is equal to a 1. Now, for example, let's say I want to change log base 2 of 8. I want to change it to log base 3. So I'll write it as log base 3 over log base 3. I'm trying to show you how simple it is. Now, the 8 is the one that goes on top, and the 2 is the one that goes below. So it's log base 3 of 8 over log base 3 of 2. That's how it goes about. Now, another way of simplifying this, though, in a way, log base 2 of 8, in a different way, it is log base 2 of 2 to the power of 3, which is equal to 3 log base 2 of 2. This is same as 3 times 1, which is 3. Now let us try to now, using all the laws that we've been learning, let us now simplify logs in different versions. Now if they say log 3 minus log 5 over log 9 minus log 25, this is equal to, now remember, when you are subtracting, you divide in logs, and when you are adding, you multiply. So in this case, this is same as log 3 over 5 divided by log 9 over 25. But there's something interesting, I think, before we do that. Now, let me show you what I mean before we do that. Let us first simplify the bottom, because the bottom seems it can be simplified. This one, log 9 minus log 25. Now, you know 9, what is 9? Log, remember when they don't put a base, it means you are working in base 10. So the assumption is everything is in base 10. But 9 is 3 squared minus log 25 is 5 squared. That's why I said there is something interesting with the denominator. Now, if you look at that, what you'll have 3 squared, remember, it's a power, it will drop down to the back there. This one also will drop down to the back there. So you'll have 2 log 3 minus 2 log 5. Now you can see 2 is common there. You can factorize 2 so that you can have log 3 minus log 5. Hence, when you continue with this method, you are going to have log 3 minus log 5 over 2. Remember, log 9 minus log 25, we were just working on it, is log 3 minus log 5. It is very important. This is part of your working, so you must not write it in a rough paper. You just divide your paper, they will see where you got it. Then equal to, now you can see the log 3 minus log 5, log 3 minus log 5. And the answer becomes, you'll get a 1 on top. It's 1 over 2, because 2 is below there. Moving on to another question. Here they are giving us again log 2 to the power 3 over log 5 to the power 3 over 2 log 5 times 2 log 3. Now what is important here is multiplication, and when you're multiplying, logs are multiplying, there's nothing you can do. Now but you can apply there 2 log 3, this is same as 3 log 2 times 3 log 5 all over 2 log 5 times, you drop the 2 there, 2 log 2. This is equal to, everything is multiplying. Now I want you to pay attention to what is going to happen. Log 2 will cancel log 2, log 5 will cancel log 5. Now you're saying 3 times 3, numbers are left, it's 9 over 2 times 2, it's a 4. Now I want you to be careful. Suppose you're given a problem like this. 3 log 2 plus 3 log 5 over 2 log 5 plus 2 log 2. What I just did is, where there was a times, I just put a plus. Now it is not allowed, remember, it is not allowed to say I cancel that and I cancel that, I cancel that, I cancel that. This is not allowed. Why? Because of the addition sign. You can only do it if there was a multiplication sign. If you are to work on this one in this version, you have to factorize. Factorize. Here, you factorize. How do you factorize? Take 3 out. Let me use a different pen now. Take 3 out there. When you take 3 out on top, you are going to have log 2 plus log what? 5. At the bottom, what are you going to take? You're going to take 2 out. You're going to get log 5 plus log 2. You see? Now log 2 plus log 5 is the same thing that you can cancel, and your answer is 3 over 2. Please be careful of that. The next question we're having is simplify log in base of 2 of 0.25 squared. Here, if I can use my red pen, log in base of 2 of 0.25 squared. This is equal to, I can drop that 2 as 2 log in base of 2 of 0.25. Now if you check, if you use your calculator carefully and you say 0.25, you will discover that it is 1 over 4. So this is same as, just say 0.25 equal to, your calculator will show you that this is same as log in base of 2 of 1 over 4. That's 0.25. This is same as 2 log in base of 2. Now you can see 1,4 is interesting because 1,4 is same as 1 over 2 squared. Remember, 4 is 2 squared. Now this is equal to 2 log in base of 2 of 2 to the power negative 2. Now we're using the laws of exponents. Do you see how the 2 are meeting? Why? When 2 goes on top, it will be 2 to the power negative. That's why I'm using that negative. Now again, I'm going to drop this power again to join the other 2 there. So I'm going to give 2 times minus 2 log in base of 2 of 2. Then what is 2 times minus 2 is negative 4. And when a log is a base and a number matching, it's a 1, and the answer is minus a 4. Again, using your calculator, you can punch log base 2 of 0.25 squared, you will get a negative 4. What is the next question that we're given? It is this question which says log base 2 of x times log base s. Let me write it in a fresh page. Log base 2 of x times log base x of 8. Log base x of 8. Now, when it comes to this method, I just want to remind you something. You can see the bases are not the same. The bases are not the same, and the key thing there is to match the bases. Either you make this one equal to the base of x, or the other one equal to the base of 2. For example, let me choose this one and make it in base of 2. If I say log base of x of 8, I want to change it to log base of 2 over log base of 2. Remember, the 8 goes on top, so I've got 8 there. The x go below, so I've got that. So this then becomes log base of 2 of x times log base of 2 of 8 over log base of 2 of x. When you have done that, you can see now this is equal to, because these are, you can see in a way this is like over 1 there. Now I can now cancel that and that. So when I cancel that, what do I have now? I've got log base of 2 of 8. Now this continues to become log base of 2 of 2 to the power of 3. This is equal to, you drop the 3, log base of 2 of 2, then the answer becomes 3 times 1, which is equal to 3. That's how you simplify that. Now let us move on to look at solving for x or logarithm equations. Now, just to remind you of a law, if they give you log in base of x of a is equal to m. So when given this scenario, what you need to know is that this particular number x, remember, x is a base and a is a number, and m will become the exponent. For example, let me show how it will happen. You are going to say a, which is a number, is equal to x, which is a base, to the power m, which is the exponent. Did you see how we just changed it? So it means if they just gave you something like this, x to the power m is equal to a, and then they say turn it back into logarithms. Remember, this is a base, this is expo, this is number. So you're going to say log in base of x, because it's a base, of the number a is equal to m. That's how they can interchange. So now let's come back to what we are going to, before I move on, we are going to use this method whenever we are solving exponent related cases. You are going to see when you start to incorporate it. Now let's come back to our question, which says log base of x of 4 is equal to 2. Now we are going to have 4 is equal to x to the power of 2. You see how we made it? Because 2 is an exponent there. But what is 4? 4 is 2 to the power of 2 is equal to x to the power of 2. And again, it's not like a law as such, but we're saying when the powers are the same, you equate the bases now. Previously, we said when the bases are the same, you equate the exponents. Now, when the exponents are the same, it also means 2 is equal to x, or you can say x is equal to 2 in this case. Moving on, let us solve this equation. It says 3 log base 3 of x, it says log x1 plus 3 log 2 of 4. Now, let us look at this. If I say 3 log base 3 of x is equal to, have my side notes here. Remember, log base of 1, any number with a base of 1 it is equal to 0. For example, if I say log base of 10 of 1, you get a 0. Log base of 5 of 1, you get a 0. So any number, any base to log 1, it's 0. So here you are going to have 0 plus 3 log base 2. Now look at 4. 4 is 2 to the power of 2. So 3 log base 3 of x is equal to 3. You drop down the exponent 2 there. Log base 2 of 2. So 3 log base 3 of x is equal to, now log 2 of 2 is a 1, so you're going to have a 6 there. You're going to have 6 there. Now, what does this mean? When you've got a 6, you can divide now both sides by 3, so that what you're going to have, log base 3 of x is equal to 3 divided by 6 is a 2. You get a 2. Now we are back to the scenario now whereby you're going to say therefore x, that number, is equal to 3 to the exponent 2. Remember that this is the base and that is the exponent. Therefore x is equal to a 9. That's how that problem is solved. Looking at the last one here, I'm going to work it quick because of time. Quickly look at the simplified version. 25 is 5 squared here. Log 5, 25 is 5 squared. And then log base of x of 36, I left it like that. 27 is 3 squared. Now, again, when you move on, you are dropping out the powers. You are going to get something like this. So now, this is the next thing that you're going to get after dropping the powers. Now, 5, you're going to have 2 times 1 is equal to 3 log base of x of 36 minus 2 times 1. So if you take 2 on the other side, you're going to have 2 plus 2. If you take this 2 on the other side, is equal to 3 log base of x of what? Of 36. If you continue on the next page, 2 plus 2, it's a 4. So you're going to have 4 is equal to, if I use a rubber there, 4 is equal to 3 log x 36. 3 log x of 36. So rewriting it, it means this is the same thing, but I rewrite so that I've got my log x on my left hand side. So now I divide that by 3 like the previous method. So I will have log base of x of 36 is equal to 4 over 3. Now when I simplify it now, what am I going to have? I'm going to have 36 is equal to x to the power 4 over 3. Now what is 36? 36 is same as 6 squared is equal to x to the power 4 over 3. Now if you try to simplify that, let me just have a look at it again. This could still go further, but it might become a bit complicated. Now let us try to use the other version here. The second method is the same, but now instead of 36, I wrote 6 squared. Now you have got 2 log x of 6 is equal to 4. Now you divide, remember 3 times 2, you divide 2 on both sides. 2 on both sides. You are going to have now log x is equal to 2 there, 2 is 2 over 3. Therefore, log base x of 6. Therefore, you are going to have x to the power 2 over 3 is equal to 6. Now, you do this by cube root. You are going to have x is equal to cube root of 6. And then you square root again. So it will be 6 squared. So x is equal to cube root of 6 squared. Now, we have come to the end of our lesson because of time. Again, go through the lesson again. work over through those logarithms. They usually bring them in the exam, 1 or 2 questions, but you need to be able to solve them. Thank you.